All right, today I'm going to be covering for pre-calculus increasing and decreasing functions, which goes along with chapter 1-5 in pre-calc. So let me start off with domain and range. So if I was sitting here and looking at domain and range, the first type of problem here is if I gave you this graph, and this graph has the function that goes along with it, which is 9 minus x squared, which means it's got a y-intercept of 9. A is negative, so it's a parabola that opens down, and it goes through 3, and negative 3 would be the x-intercepts, as you can see. Which means if I was looking at the domain, zoom in a little bit here, the domain would be, what are the x values? And eventually this will cover all x values going left and right. Okay, so that's actually all real numbers. If I was to do an interval notation, that would go from negative infinity to positive infinity, and you never actually get to either of those, you just approach them. So you put a parentheses, not a bracket. Okay, so that's the domain. The range is a little different. The range would be all the y values. I should change colors for range, which would be like the up and down. And I love it when they give me a graph and they tell me to ask about domain and range because it really makes it easier. You can see at the range, it goes from there down, okay? There's nothing above 9 on the y-axis, which means, it starts at 9 and then goes down. So since the negative numbers are on the left of the number line, I'm going to put the negative infinity, which is what it goes to, it's a lousy infinity, on the left, okay? So it goes from 9 down, put a comma in there. 9 is included, so that one gets a bracket. Once again, you never actually get to negative infinity, so that would be a parentheses, okay? Number 2, domain and range. So domain, once again, all real numbers, going from negative infinity to positive infinity, if I wanted to put it in interval notation. Range, different. Obviously, there's a limitation on the range. The range starts here and goes up, which means the range would start at 0 and go up to positive infinity. That one's not included. That one is. Okay, so that would be your range in interval notation. Number 3, this one. This one, both are going to be limited. The domain is the x values, so domain goes from here to here, okay, along the x-axis, which means it's between negative 4 and 4. And both are included. You can see that there's points there on those two values, x and negative x, and they're closed dots. If they were open dots, then it wouldn't be included. All right, so that's the domain. Range is a little different. Range would be the y's, so that's really like here to there, which means it goes from 0 to negative 16. Negative 16 is included. 0 also is included because that one's included. So there's a value for 0. All right, so that would be your domain and your range, okay? Oh, I put these in the wrong order. I should really put negative numbers on the left and positive numbers on the right, or 16 is greater than 0. So that would be the proper notation, okay? All right, next one. So this is a piecewise function, a little different here, okay? So I'm going to have a couple pieces of it. It's not necessarily going to be one notation. So domain, we'll do the domain first. So domain goes from here over, which means it goes from 1 up to infinity. Infinity is not included. 1 is. And it also goes from 0 that way. And notice how that's an open dot, which means that's not included in that value. So I'm going to have two pieces here for the domain. So it's x is less than 0, which means it goes from 0 to negative infinity. And 0 is not included because it's an open dot, so that gets the parentheses. You also never get to infinity. Now, that's the interval notation, which is probably the preferred one at this point. But, if I was to rewrite this, this would be, x is less than 0. And on the other part, it's x is greater than or equal to 1. So those are really kind of the same thing. We're going to write them both ways. Next, I'm going to do the range. And the range, of course, is the y. So if I'm looking at the y values, I got two of them. I'm going to list them individually here. The y for this one, for the one on the right, it starts at 0 and goes all the way up. So, that would be y is greater than or equal to 0. I'll do the inequality notation first. For this one, it starts at -1 and goes all the way up, but -1 is not included, so that would be y is greater than -1, okay? Now if I do the interval notation, if it's greater than 0, that means it goes from 0 to infinity. 0 is included, infinity is not. If it's y is greater than -1, that means it goes from -1 to infinity. And notice how -1 is not included, so neither one of those gets the bracket. It's just parentheses, okay? All right, so that's that problem. All right, next, find the zeros, which is also called the x-intercepts of each function. In other words, you take f of x and set it equal to 0 and then solve it, okay? So if I took this equation down here, the f of x equals 2x squared plus 13x minus 24, and set that equal to 0, and then I factor this, or if you wanted to do quadratic formula, that would work too. Let's see, 2 times -24 is -48, and factors of 48 that add up to 13 would be 16 and -3, so I can draw a line down the middle and go 16x, -3x minus 24, bring down my 2x squared also. Remember, when there's a number in front of that x squared, that makes it harder. You got to do it this way. All right, so I can pull a 2 and an x out. Leaves me with x plus 8. Over here, I can pull out a -3. Leaves me with x plus 8, which means I got 2x minus 3 times x plus 8 equals 0. And both of those things equal 0, so because there are two things that multiply together equal 0, therefore 2x minus 3 equals 0, or x plus 8 equals 0. And if you solve these, add 3, divide by 2, you get x equals 3/2, and over here x equals -8. Okay, I'm gonna assume you guys can solve a linear equation. All right, so those are the two answers. Next one. Once again, set that equal to 0. This one's going to be nice and easy, which means I want to get rid of that radical, so I'm going to square both sides of the equation, which gives me 0 equals 3x minus 2. Okay, and then solve it, add 2, divide by 3, and x equals 2/3. And there's the answer. Nice and easy. Next one, same idea, set it equal to 0 and solve it. So first thing I'm going to do is add 7 to both sides. I get 1/3 x cubed equals 7. Next, get rid of that 1/3. Opposite of multiplying by 1/3 is multiplying by a reciprocal, which is 3. dividing by 1/3 and multiplying by 3 are the same thing because, when you divide fractions, you flip and multiply anyway. So next I take the third root of both sides, which is the opposite of the third power. So I got x equals the third root of 21, or if you go punch that into your calculator, the third root of 21 is 2.76 or something. So it is what it is. It's not worth something. It's one of those two answers. Okay. All right, next. I got this one. Give myself a lot of space. All right, so I got 0 equals that whole thing. So I notice over here with the coefficients, 9 and 18, those are 2 times each other. And these are also 1 and 2 are also 2 times each other. So if I draw a line down the middle and factor by grouping, this will probably work out. Left side, I pull out a 9, it should be x squared. And an x squared, I'm left with x plus 2. Over here, I pull out a -1, leaves me with x plus 2. So then I got 9x squared minus 1 times x plus 2 equals 0. And then solve it. All right, I'm going to do it over here. 9x squared minus 1 and x plus 2. Make sure I got it right. It's all blurry. Yep. Okay. All right. So to solve this, you can do it a couple ways. I'm gonna add 1 to both sides. I got 9x squared equals 1. Divide by 9. X squared equals 1/9. Then take the square root. X equals the square root of 1/9, which is plus or minus 1/3. Take the square root of the top number and the square root of the bottom number, square root of 1, square root of 9, okay? This one's just x equals -2. So there's my 3 answers, okay? And that was it. All right, so now we're going to talk about increasing and decreasing functions. So you're really looking at the graph, and we go left to right, which is an important thing to keep in mind when you're doing this. We're just talking about whether that function is increasing. In other words, is it going up? If you're looking at the graph, up is increasing, down is decreasing, and flat across is constant, all right? So you're looking at the slope, really. Remember, slope is rate of change. Is the slope positive? If it's positive, it's increasing. If the slope is negative, it's decreasing. I'll even put that in here for a moment. Positive slope, negative slope, or 0 slope. All right, so over here, and we talk about intervals, like it's going between, this one starts out between 0 and 1. So it's increasing between 0 and 1, right? Between 1 and 3, it's constant. Okay, and between 3 and 5, here and here, it's decreasing, it's going down, okay? So that was between 3 and 5. And last but not least, between 5 and infinity, it's increasing because it's going all up from there on out, okay? Okay, and that was from 5 on, so increasing from 5 to infinity. All right, there we go. I'm not worrying about the brackets on this one, whether it's included or not. We're talking about being between two values, whether it's increasing or decreasing, so don't worry about that too much. Just put the parentheses, all right? All right, next one. This one's piecewise function. You know, it's got different pieces. It's obviously, you know, not necessarily one continuous thing. So for this one, you got to keep in mind that, you know, it's about the slope. I know it's easy to go like, gee, but before -2, it's decreasing because it's going down. But remember, it's about the slope. That actually has positive slope. So it's from left to right, which means from -infinity to 2, sorry, -2, that's actually increasing. Okay. Now between -2 and 3, it's staying the same between here and here, which means it's constant. -2 to 3. Oops, not infinity 3. Getting ahead of myself. Constant. Between 3 and 4, there's nothing. So I'm not going to put anything. It's not increasing. It's not decreasing. It's not constant. It's none of those. It's just there's nothing there. So the only thing I'm going to worry about is from 4 on. All right, from 4 on, from 4 to infinity, that would be decreasing. So this is kind of a nice thing. I think this stuff is pretty easy, but it's important. You know, it keeps coming up in calculus after this also. So it's good to wrap your head around it and hopefully get a good grasp on it. Okay. So next, we're going to talk about classifying function as even, odd, or neither. You know, if it's odd, sorry, if it's even, it has y-axis symmetry. If it's odd, it has origin symmetry, and sometimes there's neither if it, you know, doesn't fit either one of those categories. So in order to check this, just in case you've forgotten from previous sections, if it's a function, then find what f of -x is, and if you get the original function, then it's even. If you get the opposite of the original function, then it's odd, okay? And if you don't believe me, we can ask somebody else. Alexa, what's an even function?
In mathematics, even functions and odd functions are functions which satisfy particular symmetry relations with respect to taking additive inverses. They are important in many areas of mathematical analysis, especially the theory of power series and Fourier series.
That's great. Alexa, get me a soda water.
I just noted soda water in your Amazon cart and sent you some options. Choose something you'd like before checkout.
Yeah, see, that part sucks. All right, so anyway, we got that part done. Let's see. So if I take this one up here, the first one, and I plug in -x for f, you know, f of x, you know, what do I get? I get -x to the 6th minus 3, -x to the 4th plus -x squared plus 4. So, you know, those are all even exponents, which means, you know, when you take them to the 6th power, for example, it's going to be a positive. Same for this one. It'll be x to the 4th. This one will be x squared. This one will be, the 4 doesn't change. So I got the same original thing, which means this is an even function, okay? Because like it says up here, you know that I got the original thing that I started with. So that's even. You got to show the proof too. You can't just say it's even, okay? This one, if I plug in -x, I get -x to the 3rd minus 4 times -x. And with this one, I get, you know, I got negative, I get the opposite, okay? Opposite being everything is negative, okay? So, you know, if I pulled out a negative out of this whole thing, I get the same, I'd get that, you know, which is the, oops, that should be a minus, sorry, because I pulled one negative. So that, like, that's the opposite. You know, opposite being one's positive and one's negative. Okay. So that one would be odd. This one. So I know it's not there, but you know, if I wrote, this is the same thing as saying 6 times x to the 0, which means if I plugged in negative x and took it to the 0 power, you get just x, 6 rather. Anything to the 0 power is 1 except for 0, which means, you know, negative 1 to the 0 power is still 1, so you get 6, which means you get the original function, which means it's even. All right, it stayed the same, okay? This one, probably one of the trickiest ones out of the bunch. So f of x, and I plug in negative x here. So a quick reminder on, you know, rational exponents, the numerator is the exponent, and the denominator is the root, which means I'm taking, you know, negative x to the 4th power, okay? Which means that, you know, and in parentheses, which means it doesn't matter about the root, because it's gonna get to the 4th power, so you're gonna have an even number of negative numbers, which means it's gonna be a positive number once you're done taking it to the 4th power. Hopefully that makes sense. Which means it's gonna be positive, which means this is gonna be an even function, okay? These are all functions so far. You know, they would all pass a vertical line test. You know, this one here was that one's the tricky one, because remember this would be a horizontal line going through 6 up here, so it would pass the vertical line test. Okay, x to the 3rd. There's nothing I can't plug in for x. You know, so it is a function. All of these are so far. You'll have to take my word on the x to the 6th one. All right. Next one is f of x equals 2x to the 3rd minus x plus 1. So with this one, if I plug in negative x to the 3rd minus negative x plus 1, this one's a little different because, so this one will be negative 2x to the 3rd, because that'll be negative. It's an odd exponent. This one becomes plus x plus 1. So this one's a little different. You know, if I pull a negative 1 out of everything here, then I got positive 2x squared minus x minus 1, which is not the same thing I started with. Okay, so it's not the opposite. It's not the same. This one is one of those few that has the neither. It turned out to be that plus 1 that kind of made it neither instead of being odd. It was close, you know, without that, it would have worked. So that's the neither category that comes up sometimes. All right. So, believe it or not, that is all I got for today, and I'm going to close it out with a little more music. Have a great night. See y'all soon.